Okay, so I think it's time to begin. Um, Hello and welcome to this talk about Java EE, microservices, and WildFly Swarm. My name is Peter Palaga. My primary job is to be a senior sustaining engineer for JBoss EAP at Red Hat. JBoss EAP is an application server. It's the flavor of WildFly for which you can buy support from Red Hat. My relationship to WildFly Swarm is rather occasional. One of those occasions being this presentation. As I was preparing it, I found a couple of issues. I could fix some of them, and that's why I may call myself a contributor. Except for that, I'm the author of srcdeps. Srcdeps is a tool for building Maven dependencies out of their sources at the build time of the dependent artifact. This is quite new in Java. Other languages like Ruby have it for some time. And this is quite handy if you happen to deliver something big, as big as Java EE server, and your code base is divided into several independent code repositories, and the components have independent release cycles. And with these source dependencies, you have the option to define your dependencies in terms of Git commits rather than releases, and in an extreme case you can avoid releases. That was about me. My Twitter handle is at the bottom. I will post the slides later today, and you can post questions or whatever you want via Twitter to me. Today we'll start with Java EE and microservices very briefly. Then we'll cover WildFly Swarm basics, its basic concepts, basic use cases, configuration, and then depending on how much time we will have, I'll try to cover a couple of advanced topics such as secure access, service registration and discovery, load balancing, circuit breaking, and API documentation with Swagger. So to warm up, please raise your hand who ever wrote or maintained Java servlet and an EGB, JAX-RS endpoint, and the persistence with Hibernate. Great. Java is a different thing to different people, and because I assume most of us are developers here, we may adopt that perspective for now. So Java EE may be looked as a set of API specifications such as servlet, EGB, JAX-RS, transactions, persistence, and so on, that are packaged together and distributed in form of application servers. There are several implementations, WildFly and JBoss EAP being one of them. There's quite a lot of history, the last part of it being microservices of the last year. We'll come to it later. There's a few things without which it would be very hard to think about microservices. First, continuous integration and continuous delivery, which assume that you have a certain automation in your builds and deployments, which is also called pipeline. This pipeline allows you to work with smaller change sets and push them because they are small. You can push them faster through the pipeline, and they reach customers faster which is good from the business point of view, and which is also good to reduce some risks, such as it's much easier to fix a smaller change or to revert back to the previous revision than with a huge change set. Linux containers are those small, nice things that boot very fast and that allow you to spawn huge number of instances within seconds. They tend to be seen as immutable and ephemeral. If one needs to store persistently something, it needs to be into separate volume. These immutable and minimalistic images have the apparent benefits of fast provisioning, fast boot time, and when done properly, they may be quite small, and with less code, you have less surface for security problems or whatever kind of bugs. DevOps culture, preferably small teams should take care for software in its entire life cycle, from coding through testing and provisioning, deployment, and monitoring, and solving all kinds of runtime issues. So when we have these three things in front of our eyes, the notion of microservices comes rather from itself. So we want to divide the functionality into reasonably small units that can be handled by small teams, and which should not use other than language independent ways of communications between each other. It's very common to use REST or other protocols. When we do the isolation right, we may use distinct languages to implement distinct microservices, distinct runtime, data stores. They may have fully independent release cycles, and of course the teams, as I have said. Why Java EE still matters in this with this new mindset? There's a couple of good reasons for this. So first, it's robust in nature. It's well understood, mainly in terms of performance and scalability. It's standards compliant, and there's a huge amount of many kinds of integrations available, be it databases, messaging, whatever. And, which is very important, there's a huge amount of investments being done into Java EE in the past. There's code in production, and there's a workforce that knows how to code with Java EE. And once you have code in production, you should, of course, consider properly if it's better for you to re-implement things from scratch or to reuse substantial part of what you have. How can Java EE fit in? Java EE is actually a monolith by definition, because to pass the EE certification, Java EE application server has to package all the APIs. Well, you may say that there's the web profile, which allows to package a smaller part of the APIs, but most of traditional EE servers deliver just one package that tends to be quite large in terms of disk space. It's typically a few hundred of megabytes. Some of them are slow to boot and require a lot of memory, which is not the case of WildFly in the last two points. So not every application needs all those APIs, and that's exactly the mission of WildFly Swarm. It's an open source project sponsored by Red Hat, and it attempts to decomposition WildFly into smaller slices that can be used not independently, but that can be packaged together in such a way that an application brings with it only the parts it needs. It's very important to know that the way to distribute WildFly Swarm applications is a Uber jar, a self-contained jar that contains your application, the parts of the WildFly runtime that are necessary to run your application, an internal Maven repository with dependencies your application requires, and a piece of bootstrap code. There's also a related concept of hollow UberJar. It's like UberJar, but it doesn't contain any application code. This might come in handy if you work with layering in containers. You may decide to create a layer that contains the UberJar with all parts that are needed to run your application, and to place your application on top of it into the next layer. This may reduce the provisioning overhead and boot time. And this is actually also how Swarm implements microprofile. Microprofile, by the way, is an attempt to address this microservice use cases, and at the moment it contains JAX-RS, JAX-B, and CDI. For an application to require some part of the WildFly runtime or whatever capability, it is necessary to have some notion that covers these capabilities and parts of functionality. This is called fractions in the speak of WildFly Swarm. They are you can think of them as Maven artifacts, but they are not only Maven artifacts, because they provide a nice unified way how they can be configured. Some of them map to WildFly subsystems, think Java EE specifications, APIs, and some of them bring external code, such as Jolokia, Netflix, Ribbon, Swagger, and so on. The complete list of fractions is over there on the WildFly Swarm webpage. Now, a short demo with a traditional Java EE application. This is a standard example from Arun Gupta. I have cloned it into my workspace. As typical for Java EE application, it's packaging. I should unify the output. Sorry. Okay. So its packaging is warm. I hope you can read the text. Yes, it's big enough, is it? And its sole dependency is Java EE API. When we build it, the result is warm, and to deploy it, we start WildFly. As you can see, it starts quite fast, and we can deploy it with is WildFly Maven plugin, like this. So deploy it. To see what it does, it's very simple. It's some JSP page and REST endpoint that returns some list of names. So to swarmify this one, we need to take WildFly Swarm plugin, place it into the POM, save, build again, and look what's there. One of the things is the fat jar that ends with -swarm, and to run it, we just java jar the target whatever swarm jar. So the default context, application context on WildFly Swarm is the root context. So we have to remove this one and see that it works. That easy. You just add the plugin package and you are done. So where are the fractions? We have added just a plugin, and the answer is that the plugin is able to auto-detect the fractions for you based on the Java code and your dependencies. In some cases, you may want to define the fractions yourself manually in the POM file. This is what it looks like. You best import the BOM that manages the versions, and then you can use the fractions. When you are not migrating and all the EE applications, you may find this generator handy that allows you to prepare a stub for your project. Here at the top, you just put your group ID, artifact ID of your project, and here at the bottom, you can choose the fractions from the list. And you can see there the status of the given fraction. Some of them are stable, some of them are experimental. Good. Let's go through a few comparisons between traditional WildFly and WildFly Swarm. In terms of disk space, a freshly built WildFly master zip is around 150 megabytes. Unzipped, it is 177. When you have just a plain servlet in your WildFly Swarm Überjar, it's only 36 megabytes, and you see father figures over there. So a small REST endpoint with CDI and JPA requires 100 megabytes. Provisioning. The differences are quite obvious. With WildFly, you need to copy the zip, unzip, boot, configure the data sources and whatever you need, messaging queues, and then you can deploy the application. With WildFly Swarm, you just copy the fat jar and run it. It's not true that WildFly Swarm is just another way of packaging WildFly, because there deliberate decisions done not to include some kinds of functionalities. For example, WildFly Swarm will not run with a security manager. You will not be able to deploy ears. There's no clustering there because it's not really compatible with the mindset behind microservices. There's no session replication, domain management, distributed caches with infinite span and so on. And you will not be able to build a distributed messaging broker out of WildFly Swarm instances. This is still open for contributions from community if somebody finds it important enough. Configuration. WildFly Swarm allows a nice Java API to hard code configuration into your fed jar. If you look at this, and especially if you know the configuration model of WildFly and JBoss EAP, you will find it very familiar. Actually, the fractions that map to Java EE APIs are automatically generated out of the management model, management meta model of WildFly. So everything you can do over a WildFly management interface can be done also here like this directly with the Fluent Java API. When we work with continuous integration and delivery, there's a concept of stages. Each project goes over stages from development through tests and whatever further stages you decide to have to production. These stages may require a bit different settings, and this project defaults YAML file is there for you at one hand to provide the defaults and on the other hand to provide different values for the individual stages. To specify a specific stage, you will run with -s. When you are migrating from a traditional WildFly deployment, you'll probably have a standalone XML file at your hand. And with WildFly Swarm, you can reuse that file. You can either specify it on command line, or you can package it into your Uber jar. You should ensure that you have all subsystems in place that you try to configure in the standalone XML. Because with standalone XML, the WildFly Swarm plugin isn't able to auto-detect everything you have in your standalone XML because it simply doesn't look into it. And the highest level of the configuration are the command line arguments. There's a few of them, like bind to interface, select a profile, and few others, and system properties. System properties are quite powerful. They can override everything you say you set in the defaults YAML file or through the Java API. There's a full reference of the properties over there on the WildFly Swarm web page. So now we come to the advanced topics. What's the time? Okay, I think I'll break the outputs again. So Who of you knows Keycloak? Ah, very nice. Keycloak is a JBoss community project too. It provides a single sign-on server and identity broker. It provides all those security-related things that are hard to implement correctly and that are very prone to security issues, such as some of OpenID, various social logins, LDAP, and Active Directory integration. So to secure either UI or REST endpoint with Keycloak, you just need to put this Keycloak fraction into your POM XML. There's a few settings you need to do either through the default YAML file or Java API, such as you need to select the Keycloak authentication method and tell Keycloak which parts of the application needs to be secured. There's also a Keycloak JSON file where you actually specify which Keycloak host should your application speak to. Another topic is service registration. In a cloud and microservices environment where the instances of microservices are being created and destroyed very fast, it's not very useful to rely on IP addresses and host names. That's exactly the mission of service registries. Your application, your instance of a microservice is supposed to register itself under a certain name in the registry so that its dependent services are able to find the IP addresses and hosts through the name under which the service instances are running and are ready to respond to the requests. So Consul is just one implementation of a service registry that WildFly Swarm provides out of the box. To use it, you actually don't need that piece of Java code. This is just showing what it does by default. The name of the application is equal the name of the service under which your application is advertised is equal to the artifact ID in the POM file. This comes from example. This is called Ribbon Consul on the under WildFly Swarm GitHub organization. Further, there's Netflix Ribbon, which may be used to do the invasive part of service registration, which means service discovery. You either use Netflix Ribbon or you can use a Consul client manually or directly in your Java code. Netflix Ribbon does a lot of other things in addition to service discovery. It's a general purpose inter-process communication library for REST microservices. It provides client-side load balancing to other services, and it offers several implementations such as round-robin, response time weighted, or random. As I said, there's integration with several service registries, and there's a built-in support for failure resilience via Hystrix. To use Netflix ribbon, you add the usual ribbon fraction to your POM, and to create a proxy or an ad hoc client that communicates through all the complicated ribbon logic, you create an interface with a resource group annotation that references the name of your the name under which you have registered your microservice, and the lookup is done by console fraction under the hood. At the bottom, you can see how to instantiate that. You can do it via ribbon firm, and it creates an instance of your interface dynamically. Okay, Swagger. As usual, you add the fraction. You configure it either via Java API or whatever other option you have, like a system property or a YAML file. And once you have it, this is what you get when you request the Swagger JSON. That's basically it. A small recap. WildFly Swarm is just enough application server that packages just the parts of traditional Java EE server into an Überjar or into a hollow Überjar. There's a notion of fractions to specify and configure capabilities. And there's WildFly Swarm plugin and plugins for Maven and Gradle. To keep in touch, you have several ways. You can read documentation, visit examples, ask questions on the forum or IRC channels, post issues, or there's a Twitter handle where you can follow. Thank you very much. Are there any questions? No questions. Thanks.